Okay, hello everybody. My name is Knut Brandrud. I'm a program manager in the enterprise search team back in Oslo. And as you guess, I'm one of the fast guys, coming from Fast Search acquisition a few years ago. I've been working with the fast search technology for many years. So today we're going to talk about search deployment. Also introduce my co-presenter here.
Yep, my name is Darren Allred. I just presented here last, so if those that you've came for our troubleshooting session, you'll get some more of me. Just for those that weren't in the earlier session, I'm a solution architect within the Microsoft Consulting Services. Also came with the FAST group, so I'm one of those people. And I'm happy to be here and excited to be working with Knut today and talking about deployment. Okay, 2013.
Okay, so today you're going to learn about the SharePoint 2013 topology, search topology, how it differs from the previous version. We'll talk about how to deploy search topology with high availability. We're going to talk about how to keep your topology healthy, and a little bit about day-to-day operations that you typically do as a search service administrator for this farm.
All right, so let's start out and just briefly go through the topology. By raise of hands, was anybody here for the previous session? A few of you. So this is a little bit of rehash for those. I'm just going to go quickly through this, talk about the 2013 architecture. As many of you know, in these sessions today, we have a brand new engine in a core with 2013, a unified architecture. From the crawl side, or the content side, that starts with the crawler infrastructure. Those that are familiar with 2007, 2010 will be familiar with the crawler infrastructure here. We continue to maintain that, or that continues on in 2013, that same crawling infrastructure. The content processing it comes from the FAST side, and that's a workflow engine that we provide there. That's a new content processing components. From the right-hand side, the queries come from the web front end. That's SharePoint componentry from same as 2010, 2007. As we go through and down to the search core, we pass through the query processing component. That's also a workflow engine that we have new in 2013, similar to the content processing actually, and provides the enrichment, query enrichment. In the center of it all is the core search index, and that's where the magic happens. That's where final queries are matched against content that's indexed and returned to the user. Again, a new core for 2013. In 2010, Fast Search for SharePoint 2010, for those familiar with that, we had a web analytics, a web analyzer, a link analyzer for 2010. And that really formed a basis of an engine that we have now fleshed out in 2013 and has become what's called an analytics processing component. So this is a new capability within 2013 that provides, in addition to web link analysis, things like recommendations analysis and user profile and item-to-item recommendations. So lots of new functionality and capability there. The search topology in 2013 is core and central to SharePoint 2013 as a whole. It's a vital component of 2013, and it powers many of the workloads that you have heard about. Some of the new features, the social, discovery, WCM features that are new in 2013. So I think it's safe to say that without a doubt, the 2013 search core is really a vital, more so than ever, a vital component of your search topology, and it provides this kind of foundations for scalability, both on the query side as well as the content loading. So it's important to get it right so you can have a fast and scalable search core. It provides new fault-tolerant capabilities than we've had in the past, including we've had fault tolerance across many of the components in the past. Content processing, the index itself, those have all been there. One of the key new capabilities that we've provided in 2013 is the fault tolerance around the admin node, and that's something that we're really excited about, something that users have asked about, administrators have really wanted for a long time. So that's an important new capability that we provide in terms of failover. As I mentioned before, it's a unified search core in 2013. So this shows up as a single unified search service application. Those that have worked with Fast Search for SharePoint are familiar with content and queries SSAs. Also, you've got the SharePoint Enterprise Search SSA. That's all consolidated now into a single search service application, greatly reducing the complexity in terms of the topology management, configuration, and really even just conceptually, it makes things much easier to understand. Yeah, you have the ability to, both through the when PowerShell and through the UI, to be able to retrieve status of the components within the search core. So we have some key new PowerShell commandlets that are available to you to retrieve the status of each individual core. And we'll show you how we've taken that and extended that here and in some of our demos today. And then, of course, the UI itself shows you have visibility on the current state of each component in the farm.
Okay. There it is. So one question, how many of you have been working with SharePoint Search 2010 in the past? Quite a lot of them. And how many have been working with Fast Search for SharePoint? Mm-hmm. Not so many, but a few. Yep. That's nice to know. Good. Okay, so this is the search architecture that you are probably quite familiar with from SharePoint 2010, with the crawl component, query component, where you have sort of the index is stored, is stored partly in the property store for the managed properties, and the full text index on local disk. What happened in 2010 is that we got the addition of Fast Search for SharePoint. This was integrated into the 2010 project at a little bit late stage. That's why it ended up sort of halfway integrated. So we had the backend components of Fast that was managed separately. And it was integrated with the content and query SSA. And that way appeared very much in the same way as the standard search. And we added some new capabilities with Fast Search, the content pipeline and the query pipeline, including extensibility capabilities in the content pipeline. So what you see is that the architecture for SharePoint 2013 looks very much like Fast Search for SharePoint, and that's not a big surprise because the foundation is very much the same. But now it's fully integrated, and you have everything in place inside one search service application, as you can see. But we have the same scalability and flexibility. So we have removed sort of the property store, so everything related to the index is on local disk. That's important for performance and also makes it more flexible. We have separated crawl and indexing, so we have these three components in the feeding pipeline: crawl, content processing, and indexing. And we have the new analysis component that Darren talked about.
Okay, let's talk a little bit about where these components actually live on the farm. So there are actually two, and for those that are in the presentation, I talked about this briefly. I'm going to go into more detail now, and that is there are two primary processes or parent processes that manage the search farm. Those that are familiar with SharePoint Search will recognize the MSS Search exe. That is actually the container process, the parent process that houses the search service application and the crawling itself. So it manages the crawl. The host controller service is the host service for the rest of the search components. Those search components show up as what's called node controller processes. And later, when we go to a demo, to our demo environment, I'll show you how you can identify those processes as they're running and how they relate in terms of their inheritance there. But conceptually, this is how they fit together. So all your query, admin, content, index, and analytics run underneath those node controllers. So it's important to note that the MS search process is the same as in 2010. It is the same service, but it is limited to only the crawling portion of the service. So it is no longer responsible for capturing metadata, posting that to the properties database, and is not responsible for actually creating an index. Okay, so that's now the core indexer's responsibility. So for those that are familiar with the responsibilities of the crawler, that's its new role. It's just the crawl component. And I'll just note this actually that the query services that you are aware of in SharePoint 2010 or SharePoint 2007, the responsibility of the query service, query service itself, is to pass that the queries on to the back-end search. There's no index that is held and searched on your web front ends. That doesn't happen. The web front end just passes those queries on back to the search core. So as I mentioned, the node runner processes are the containers for the search components, except for the crawler. And then there's another entity within the search topology. It's called the admin entities, and these are the search service application and instances. And these aren't processes per se; they are simply configuration objects within the SharePoint 2013 environment. So these exist within the in the crawl database, and crawl admin database. They're not actual processes.
Right. I'll briefly go through high availability. I don't want to go in very much detail because that was covered in the presentation yesterday, SPC 172. So I hope some of you got that. But just to give you a quick overview, I mean, here we are listing sort of different characteristics of the different components when it comes to high availability. What I would like to call out a little bit separately is the host controller, which is not a component, search component from the topology point of view, but it still has a high availability role in the farm. It handles a repository for search dictionaries, and there is a primary, secondary role related to that repository role. So the only time when you actually need to care about that is when you have a hardware failure and you have to replace a server, and then you would normally need to check if that server actually hosted the primary host controller. In that case, you need to use a commandlet to replace it, and I'll come back to that later. So then we go into sort of how you can set up your initial search topology. Expect you have installed your SharePoint farm. You may or may not have sort of an out-of-box search topology, depending on how you install it. But I mean, anyway, you only get the single node search topology from the installer. And then you would probably want to have high availability. You may also want to have some more performance. Maybe you want to have handle more than 10 million items in the index, and you need to have more nodes. So that's why when you need to scale out the system initially. So of course you need to prepare your servers, and it's important to consult sort of the hardware software requirements to make sure that you have a sufficient amount of memory and disk for your servers. The presentation yesterday I mentioned did go into more detail on that. You install SharePoint on the new servers, you add the servers to the farm, starting your search service instance, which is sort of the provisioning of search on each box, and you create your search service application. Or typically, depending on how you install, you may or may not need to create this SSA. It can be already created for you. Okay, so what you do, you create a new topology object. So you have an active topology object that has the running topology, if you have done it like that. And then you create a new one where you sort of deploy or populate your new components. And this is the commandlet for doing that. And then you add search components to that topology, and you have separate commandlets for each component. The example here is for the index component and for the query processing component, but it's corresponding commandlets for the other components in the topology. And then you activate the topology using set.sp enterprise search topology. And that will go on for some time. There's a lot of housekeeping going on inside the farm when you do the activation. So then you have your new topology, and you can start and crawl your content. If you need more performance or more capacity later on your running deployment, maybe run out of capacity for the index, then you typically scale out your farm. And you do it a little bit differently when you have sort of a running installation with already indexed content. Then you create and edit sort of a copy of the active topology. That means you use the clone parameter when you create a new topology object. And this is because you cannot, or you actually are not allowed to modify the active topology object directly. And then when you scale out, sometimes you only scale out by adding new components on new servers. In other cases, you want to reshuffle some of the components and you move someone. And if you move components from an existing server to a new one, it's important to do that in 2 steps. That means you add the components that you on the new servers before and activate that topology. Wait until it's green. That means all components are performing correctly before you actually remove the component from the previous server. And the reason why we want to do that is that if you don't do that, if you do it in 1 step, you may be a little bit more vulnerable for errors during the operation. And you also have a short period where you don't have high availability for your farm.
Okay, so I'm going to skip through this. I'm going to come back to this topology really quick. I'm going to drop to this demo environment, and then we'll come back and talk about it. Just kick this off here. So I'm going to switch over to a demo environment. Okay, so this is a typical 2013 central administration screen. I'm going to go in and manage the service applications. What I've done prior to setup is I've already created a search service application and instance on my farm. I've actually got a 4-node setup. I have 4 servers that are participating in this farm. And what I'm going to do is we're going to deploy that 4-node search topology. So just jump in here, show you the search service application. Search application, like I said, is up. So the admin databases, the crawl databases, link databases are all created. But there is no active topology right now. So we're going to kick that off, and then I'll tell you what's going on here. So we'll start that process. The command simply, well, I'll go into details here. The command uses 2 primary files. One is a deployment configuration that references all the different servers in my farm. And conceptually, here's what I have set up for the farm, is these VMs assigned to these roles. So let me flip back and just show you the picture of that as it's running. And we'll come back to this. So out on TechNet, we have a kind of a recommended high availability, kind of small search topology. And the configuration that we have set up that we're mirroring here is, in our demo environment, mirrors that topology. So each of the components, the index, the crawl, admin, analytics, content processing, and query processing are all mirrored, not just across VMs, but if you notice, there's physical hosts there. Now, in the purpose of our demo, we have an environment, we don't control the physical assignment there, but the point being here, the recommendation here is that, the best practice here is that fault tolerance really is best if performed across physical boundaries, right? You get that's true fault tolerance. So here we're showing demonstrating that in the demo environment, but in reality, you'd want to make sure that those high availability components are across physical hardware. So we've got 4 VMs, like I mentioned, and we're mirroring and we're creating a replica of the index across these components. Okay.
And Darren has been so kind to create this script so you can easily be reused by you guys, and we will make it available on the net afterwards, so you'll be able to get it. Yeah.
Yep. So another thing, just wanted to note here, well, a couple things. One, the part of that TechNet guidance is to also provide redundancy at the SQL layer. That's really important to provide that kind of redundancy. We don't have that. We're not showing that. We just have a single SQL environment. But in practice, you would put either have a clustered mirror configuration there. And then another thing to note here is that there are a lot of times customers ask questions, or administrators want to know what components really should logically fit together on these servers. And so what we've done is there's some guidance there to provide so that you can, we recommend is putting things like the content processing together with the analytics processing. Those are very common and correlated functions, and so fit well together on the same server. Admin server can go together with crawl components. Typically, the admin server is it doesn't require a lot of CPU, memory, or disk, and the crawl processes can live there quite nicely with the admin components. And then our index component lives really well alongside the query processing, where it participates in returning or responding to queries from the server. So we've got that set up. So I'm going to flip back over here. So as I mentioned, we have this configured in deployment configuration here, our 4 VMs. And if you see here, I've got admin nodes across VM1 and VM01 and VM03, crawl, content processing, analytics processing, all mirrored across the VM01 and VM03. I've got an index partition, single partition, 2 replicas mirrored across VM02, as well as query processing. And then in our case, this is another thing to note in the diagram, the topology referred to just the search services. Since we have kind of a standalone farm here, we've also provisioned central administration web front end, but those would be, in a large scale out, those would be scaled out appropriately based on number of content databases and other criteria you have for the other service applications as well. But for our purposes, we just have kind of a non-fault tolerant central admin and web front end. So back to the screen here. So as I run this command, you see that it spits out some information, just tells me that it's detected that I've configured the various components: search servers, admin, crawl, content processing, analytics, query, and index servers. And then what the provisioning does is it creates a new topology, and in this case, it's a blank topology, so it creates a new empty topology, and creates new components. And so each of these highlighted, this output that we've put here is just showing you the different types of components it's creating. So it's creating new search admin components, just like we told it, across the new nodes, crawl components, content processing, and such. So the search topology takes, kind of initially, it'll take about 4 to 5 minutes to generate here. As it comes up, I'll just see if we have anything here at this point. Probably not. If not, I can switch to we'll let it load here. It'll continue. What I have is, I'll show you what that looks like. Let's see, here we go. So when it finishes the topology activation, it will then spit out it'll tell you, report back to you what what components are running on each of the services, and then when you go to the central admin, and we'll come back to it a little bit later when it comes up, but we'll see this that all the services are provisioned here across the board. So let's switch back here.
So I'll talk a little bit about how you should sort of lay out a disk system and locate sort of the data folders for search on these servers, because that's quite important. I mean, there's a lot of things going on disk, of course, in this system, especially for index files. as the entire index is running on local disks. So they are quite I/O demanding, the index operations. So please be aware of that. What you typically can do is you can specify the location for data files, search data files at install time. Here is just a screenshot from the installation UI. So the red one below there specifies the data folder for search. It's actually for all search components in this case, even if the text there is not completely specific on that. But you can do it another way as well. And you can have, so in addition to set up a separate folder for search data, you can also set up a dedicated folder for the index itself. And that's what you do that when you create your topology and you set up using this new SP Enterprise Search Index component commandlet, as you saw in the previous example here. It's also recommended to consider sort of having a separate location for the ULS logs as well, to prevent them from flooding sort of the same disk system as used for index, for instance. And it's important to keep in mind that there are some changes from 2010. Some of you may be aware of that you could sort of change the index folder or set the index folder on the search service instance level. That's not supported in 2013. So you have to do it in the other way by using sort of this parameter to the topology commandlet. So this option to set SP Enterprise Search Service Instance is no longer supported. Okay. Maybe you want to say a little bit about scaling out?
Yeah. So this just finished. Let me just switch back a little bit here, and I'll just show you that final partitioning, and I'll come over to this here. So as I mentioned, the provisioning is completed. It's printed out the active components here, and then if I go back and I've refreshed the search service application here, you can see that the topology, I refreshed that, you saw it. Yeah, is provisioned. So there you've got the 4-node provisioning, admin, crawler, content processing, query processing, index partition. So there's your new topology, as promised. Yes. Okay. All right. So this is something that I think is really exciting in 2013, something you should pay attention to. In the past, repartitioning or scaling out the index has been challenging. Takes some effort and planning, and in fact, some of our customers have taken the route of just sizing kind of well in advance, right? Just provisioning way in advance of the need, just to avoid this kind of a repartitioning kind of event. Part of this is because of the manual nature of it. Part of it is because of the downtime required for repartitioning. In 2013, we have native support for repartitioning of the index. Okay? You're going to clap? Yeah? I'll clap. Yeah, that's great. I love it. So we're excited about that. So when you get your partition reached as 10 million items, and that's the best practice that we have, 10 million items, you would be ready to scale out your index. Okay? So in this case, we're showing going from 2 to 3 partitions with 2 replicas each. Maybe, Knut, you can explain a little bit about this, the way this works, because it's something about stateless partitioning I think you tell us about.
Yes, that's right, Terry. Basically, we have changed the way you route content to the different index partitions. Previously, I mean, we still use a stateless-based hash routing, but we now use a consistent hashing, which means that basically the main difference is that whenever you repartition the index, of course, the hashing will change, so that you want to have an even distribution of content across another set of partitions. When you use the consistent hashing, you avoid sort of the need for reshuffling all the content across the partitions. Only the stuff that actually has to be put on the new partition is really actually moved. So that means that the repartitioning is going much faster than before. So that's
Yeah.
quite good.
Awesome. Well, congratulations to the engineering team for doing that.
Thank
This
you
is
very
great.
much.
It's a new, really, we're excited about this.
We as well. Yep.
So there's more detail to this. I think there was something that we talked about as far as being symmetric, and I wanted you to try to describe to people what that means, what we meant by being symmetric or having a symmetric index layout when you size out. Can you describe that a bit?
I can do that. I mean, basically, in the previous product in the Fast Search for SharePoint, you had to have sort of, then we talked about rows and columns, and you were forced to have sort of exact same number of rows across all the columns, which columns was the same as partitions. In 2013, we don't have that strict requirement, but we still recommend that you have sort of the same number of replicas across all partitions. Obviously, that's important for the performance of the system, because you don't get more performance than the sort of least the partition that has the least number of replicas. And of course, you want to have HA on all the partitions. And in addition to that, there is a requirement when you do repartitioning, you need to have an even number of the same number of replicas on each partition. And you should also make sure that when you add the partition, you put the same number of replicas on the new partition as well. You don't want to add a new partition with only one replica in the first place, because then you would have a short period of time where you are more vulnerable towards hardware failures. And as we know, hardware failures very often happens when you do operational stuff like this.
Yeah. Another thing Phil mentioned, we also, it's not completely great. I mean, you got the symmetric thing, but you also do have to plan a bit ahead. It is automatic, but there is some downtime there during that repartitioning time. So you do have to plan for that. But there is no manual effort involved in actually doing that partitioning. So that's great. Okay. Oh, wait, got me a video. It's my video time.
Yes.
All right. Okay, so for this, we wanted to actually demonstrate how this works. And it takes a little bit of time, so what we did is prepared a little video to do that, and I'll talk you through this as it goes here. So let's switch over. Okay, so this is the search service application that we had. Okay, and we've got the partitions there, a single column. First thing I'm going to do, because this is an empty index, so I'm going to go in and set up some contents, or crawl some content. And so I decided to crawl Microsoft.com. Sure, why not? So we'll go ahead and select as a website, and then put in a start URL, www.microsoft.com, and then
It takes some time to crawl the entire Microsoft.com.
yeah, it's going to be amazing how fast this is going to go. Watch this. This is really cool. This is how fast. This is improved performance right here. Let's check it out. Okay, so I'm going to start all the crawls. Look, hands, no hands. Starting. Hit start. Okay. All right. It takes a little bit of time. Okay, it's crawling. And look at this. I'm going to go to the crawl log. Oh, I've already got like 15,000 documents in there. Sweet. So I don't need any more, so I'm going to just stop that crawl. And,
Really fast crawling. Yeah.
Yes, very fast crawler. I probably got some notes from the Microsoft.com web team. Like, what are you doing? Hitting my site. Okay. So just to show you that this is real, do a search. Yeah, that's real. Okay, we got some content. Sweet. Okay. So, thanks. So, okay, so this is and I want to just show you this here. So this is our first partition. I showed you this already. We got the one partition index, right? And I'm just going to do this little magic. Watch. Boom. 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 See, there, I'm going to add one more index. I'm just adding another replica there. So here's the command, the same command I ran before. Now I'm just going to you can hardly say a config2 partition. So I'm just applying a new topology. Same kind of output that you see there. Amazingly, this goes way faster than the first time. So, I mean, I love that. And so it's going to run. I'm just showing you there that this is actually provisioning across these new machines. And then And then it will spit out the output here. Yep, there it is. Done. Wow, it's already done. So at this point, it's actually migrated the documents. And I can show you there the new partitions that have been created. We've got now a new index component 4 and 3, again, against these new servers, or well, existing servers in our farm. And finally, if I go back in and look at find the search administration button, and I look at that, and I go, I scroll down. There you go. So we got 2 partitions, and that's it. That's exactly how it works. Now, like I said, it takes some time to do that, and of course, a big index will take a lot of time, and you have to prepare for it. But just showing you here that once I'm done with that process, search just operates just like it did before. Goes on.
Excellent. Thank you.
Cool.
Okay. I'll jump to a little bit different topic, talk a little bit about sort of how you would handle the challenge of multiple farm deployments, which is typically a case for many customers, that they have department deployments. You can have a multinational company with different farms, different regions, things like that. How to handle that when it comes to search. And in general, in most cases, we recommend to handle that by using a central search farm. That means you have set up a federated farm that actually performs the crawling and serves queries for all the regional farms. That means that when you push the sort of search button in the various regional farms, you get the query results from the central farm. That's, in most cases, the best approach. It gives you an easier administration of the search topology and the search service in general. It gives you better relevancy because everything is indexed within the same rank model. So it's taking care of all the sort of the consolidation of click logs and things like that, and also user behavior. So you get all this sort of consolidated in one farm, which is good. And that also the end user experience is better because you get one consolidated search result across all the farms. You can do it another way as well. I mean, there can be reasons why you want to have a distributed deployment for search as well, which means that you add a search index in each farm, and you sort of by default you get search results from the local farm, or you can use a federation to federate results from the other farms as well. And when you use federation, you get sort of separate result blocks for each federated set of results from each farm. There has been other sessions describing the federation approach in more detail, so I don't go into detail on that. And of course, we also have the hybrid situation, which is a quite likely scenario for many of you, I guess. If you want to have sort of a gradual move towards the cloud, it's convenient to do a hybrid migration and have certain parts of your content and services in Office 365 farm, and then federate in results from regional farms, which could be stuff that you index from line of business applications or other content that is not really practical to add to the cloud yet. And a little bit about sort of when you would decide to use federation rather than a central farm. There are situations where you have slow connections between the regional farms. Then it can be inconvenient to do crawling across the WAN. There are obviously regulatory restrictions in some cases where it's not practical or not possible for legal reasons to have sort of a central farm and consolidate all the content in one place. There can also be situations where the content is logically different between the different regional farms. I mean, there can be different parts of an organization that doesn't necessarily collaborate that much together, and in most cases you will want to have local results. And of course the hybrid situation, which requires federation. Okay, then we go to next part of the presentation, talking about how you can keep your search topology in a healthy state. Of course, that's important. We have different sources of diagnostics in the system. And first of all, we have the system and component state that we have already been touching. You have seen it in the demo, how you can get sort of the state of the different components and the partitions here. You see everything is green here, no problem. Everything is working as fine. But you can have situations where yellow or red icon pops up here, then you need to do something. So it's nice to start out to look at the UI, and if you want to have more details when it comes a yellow icon up on the screen, then you can use the new PowerShell commandlet, get SP Enterprise Search Status, which is a convenient way to get more detail on the status for the different components. The health reports is a nice source of diagnostics. It was more in-depth covered in the previous session before lunch, so I think many of you attended that one. And of course, we have the telemetry in the form of logs and performance counters, ULS events, and if you're using SCOM, you can get the ULS events rolled up in SCOM with alerting as well. So, if you have situations where components show up as degraded or degraded in the commandlet or yellow in the UI, it's important to know what that actually means. And in most cases, the yellow state represents sort of a transient situation. It's part of the life cycle of the components. It could be related to restarts of the component or topology changes. Then you will have a shorter period of time where the component will appear as yellow. So you shouldn't act instantly. You should sort of monitor a little while, and just ensure that the yellow state is going away, which it normally does. There are also other cases where you see a degraded state related to the indexer, and that's not really necessarily any error. It's just a part of the life cycle of the index components. If you have a new replica deployed, then it will be seeding from the primary replica for some time. That means that the index is copied to the new component, and because there could be a rather large amount of data, it will take some time, and you will see that the component is yellow. And it's, of course, it's important to keep in mind that as long as the component appears as yellow, it cannot really take over if the other fails. So you have a degraded topology. You don't have HA until the new replica actually is seeded and green. So that's important to keep in mind, and not do any other operations during this period. And there is a shorter period of catch-up where a replica has been sort of restarted or been patched or out of operation for a short period of time. It will still have its index, but it will need to catch up from the primary replica to get the journal, the replay of the journal. That means the items that have been added since the last index was created. And the red state means there is a failure. In most cases, there is a failure related to network, to hardware, and in the commandlet, you will see that appear as unknown, because the topology system doesn't really know why. It's not able to reach this component, so you cannot really say why. So you only see that it's unknown. And you can use the commandlet, as I mentioned, to get more detail about what's going on, especially for the degraded states. So I mentioned this commandlet, get SP Enterprise Search Status. This will be your friend, and you should use that to figure out what's going on in the system when everything is not okay. So you get the basic component state, red, yellow, green. You get, if you need it, sort of figuring out who is the primary admin, primary index component. In most cases, you don't need to know that, but in certain cases, it's nice to know. You can see the status of the analytics jobs. That means you can see the last run, if there's been errors in the analytics run, next scheduled run. It's nice to see if something goes wrong, but also relevant to know when the analytics jobs are running, especially if the analytics component is running together with other components on the same server. And you can get a lot of additional detailed diagnostics data for the indexer, housekeeping related stuff. Okay, we have created also an additional script that makes it easy for you to manage sort of the state. So it consolidates all the data that you get from this the SP Enterprise Search Status commandlet plus other sources of information, including the crawl status. You can see if the crawl is paused or sort of what phase of crawling it's in. You see number of index documents. You see sort of alerts if you getting close to or exceeding the recommended maximum number of documents per index. And you can also get an easy overview of the HA state for the topology to show which components that doesn't have full HA at a given point in time. And also the host controller dictionary repository, as I mentioned. And we give you here the link to the TechNet Wiki page where you will find that the article where you can actually can download this script.
Right. Okay, so we're going to show you this. Am I on? Okay, good. I almost fell off of this the other day, so I'm really paranoid.
Yeah.
Okay, so I'm going to switch over to our demo environment again. And I'm going to show you the search component state here. So if I run the search component state, I'll get back a list of the current components that are running, and it'll tell me ones that are in good state. And in this case, all my components are running in good state. I've got my partitions, my crawl components there. I can see from this where my primary search host controller lives, and we'll talk a little bit about what that means and why that's important. Well, here it says for dictionary repositories, but we'll talk about that a little bit more. And then also it tells me the servers have multiple search components on them, so I can see the servers where content processing, analytics, crawling, index partitioning, query processing occurred. And then, in addition, there are jobs that run as part of the analytics component, and the state provides me additional detail in terms of the current running jobs on that analytics engine on the back end. So these are kind of MapReduce type jobs that occur to do all the web analysis, web link analysis, usage analysis, and reports. So one thing I wanted to show you before, and I'll take a little bit of time to do that here, is that
Sure.
I wanted to show you the processes and the parentage. I mentioned that kind of back before. So on a running system, let me just zoom in here on this node here. So if I zoom in here, I can see there's this host controller service right there. You see the node runners running into there? That's the host controller that we've been talking about before, and that's the one that's housing those back-end search components. So if I zoom again in over here, actually let me zoom in live here, and you see these processes. I can see here that this is actually an admin component. This one here is let me just cut it a little over here. There it is. Oh, that's not showing me there. It shouldn't show me, but here. Let's put it under here. It is a content processing component. Okay. And then I can see that this one here is an analytics processing component. So those are the different components that are running on that server. And if I were to go to each one of the servers, I would see that that they all have node runners running, and there are different sets of them based on the number of services, a number of components that are running. So on my number 2 VM, I've got 2. I've got 3 on number 3 VM. And then on 4, I've got 2 additional node runners. So that's the one. And then another thing you'll notice here is the MSS search process. And that's this one here. That's the one that houses the crawling components. Represents the search service instance there. And then underneath them, when it's crawling, the MSS daemon process actually show up. So again, that's how that correlates when you're looking at the something like I'm using Process Explorer, great tool provided by Mark Rasinovich group. But if you Task Manager or whatever, you can see what's running there and understand what's running on your system.
And if you, for some reason, need to restart the service, the search services on the box, you restart the host controller, not in individual node runners, because the host controller will then restart all the node runners on that server. Okay. Health reports. I think I won't spend too much time on that because it was well taken care of in the presentation before lunch. Just very brief overview. So on the query side, we have this health report that you see in the search administration UI and the diagnostics. So you have the query performance type reports for latency and query rate. You have the federation reports where you can see sort of the performance per source, per federated source. My favorite is this query and feeding correlated view, where you can see the query latency correlated with the feeding rate, both for analytics updates. That means partial updates based on the analytics runs and the normal feeding from the crawler. This is quite convenient. We can also then see how much influence the feeding has on the query performance at a given point in time, and see if you need to scale out things. On the content side, we have a number of reports that is useful. I mean, if you care about what happened to the document, you look at the crawl log. There was a lot of useful information about that in the previous session. And if you worried about what happens with the feeding, if you have problems with performance, or then you would look at these reports, looking at the crawl rate, crawl load, and the latency. And there's more details on the crawl log as well if you look at the recording from SPC 044 earlier this week. Okay, some of you may use SCOM for monitoring. I mean, typically you monitor SharePoint in addition to other components using SCOM. We have some nice views of the search topology in SCOM. You can, under this Microsoft Office Server Search node, you can look at the server view, where you can see each host controller and the host control node and each server. Below that is part of the search topology. And then you have the component view, where you can see the health of the individual components based on the events, ULS events, that gives you an indication about things going on that is not healthy. So if you sort of use SCOM as sort of the common place, one-stop shop for health of your systems, then you can, if you get indication here, something's wrong, then you go into your search UI or this set enterprise search commandlet and see and get the more details on what's going on. But this could be a nice way of getting the overview from SCOM. And you have some nice monitors that you can get from the out of the box using SCOM for search. This is just some examples of what you can get. You can get here. You have a situation where analytics is not able to run correctly. Go back and look at sort of what's happened. Is it underperforming? Maybe you need to scale out analytics. Missing partition on the index side typically means that there is something going on with the topology. So you can easily figure out that by going back and look at the search topology state. And there can also be indications like this related to to the dictionary repository and the replication of the repositories. Then you go back and look at the status of the host controller using PowerShell. And there's a nice TechNet, or a set of TechNet articles on this address that gives you sort of all the SCOM monitors that you can get out of the box. Okay, the last session or last topic for today is to quickly go through the key day-to-day operations that you would typically do on your search farm. I guess you will have a daily schedule like something like this. I mean, you start of the day, you will check the topology, starting out with the UI probably, and go monitor in more detail if you see issues. Should look at the content freshness to see that everything is going right, no problems with latency. Look at the health reports, and investigate if you see components that is not green. And regularly, you will have other type of tasks that you perform to monitor the number of documents per partition, so that you are able to sort of plan repartitioning in due time if you see that you are reaching sort of the limits on 10 million documents per partition. So you should really do the repartitioning in due time before you get to that limit, also because you want to plan and schedule that to a time when you don't have too much traffic on the system. Backup is an important aspect as well. Security updates, other product updates, and sort of maintenance and replace hardware when it's failing inside the topology. A little bit about the backup and restore operations. When you talk about a backup, I mean, we need to emphasize that everything except the index is stored in databases. So the index is in local disk, and the rest is in databases. When we do a backup, it's important that everything is in sync, so you need to have a synchronized snapshot so that the state in the index is the same as the state in the crawl database.
I know that a lot of our administrators today struggle with backups. So, and I know you're going to talk about this, but I know that one of the things is just that what you're talking about right there, having things in a steady state. How is it in 2013 is that better, or how do we address that?
Yeah, I guess you have experience with your customers as well. I mean, the problems of how to set up a disaster recovery solution in a reasonable way. I think we make it much easier this time, and it's easy to use backup and restore to handle sort of the replication of state between the primary location and the disaster recovery location. So it's quite convenient to use. You take a backup on your primary location, and then you can restore that on a different location. So you don't need to restore on the same location, as long as you have the same set of components on the DR location. You even don't necessarily need to have the same number of servers, but you need to have the same number of components. That's the requirement.
So that sounds like a significant improvement over 2010, where backup and restore would only be to your kind of current environment. Now this allows you to really implement more of like a staged environment through using backup store or better disaster and recovery.
Yeah, I think we have also improved the robustness of the backup procedure, so it's quite it's very reliable. We use it very regularly in our own service environment as well. I mean, so it works very well, and it's faster than before. So this is some ballpark figures. So if you back up an 80 million document index, it could take something like 8 hours and represent 2 terabytes of data or something like that, and a little bit faster to restore it. So that's reasonable. So you typically would like to do backup and restore using the standard SharePoint approach. I think that's normally what we recommend to you. There are, however, other ways to do it as well if you have special requirements. I mean, we have procedures. You can get the procedures on TechNet for running a DB-only backup if you need that, typical case when you do that is if you, for some reason, need to move to another DB server. Maybe you want to decommission server, maybe upgrade to another SQL server, whatever. Then you can do a DB-only backup. Typically, you would pause the search system and do the backup with the rather limited impact on the system itself. Some customers would have requirements that they want to do their own backup using VSS. Then they can control the backup themselves using selective snapshots of the system, including the index. This has some advantages if they want to have sort of this controlled by their own application, but they need to be aware that search will be down for a longer period of time if you do it like this. And the reason for that is that we have a more flexible and a better way of handling the standard backup. As I mentioned, it has to be consistent across all the databases and index, but we have a two-phase backup, very much similar to how you typically do it in database systems, where phase 1 backs up the current index. And during the phase 1, which is the longest period, then the indexing itself is paused, but the feeding continues. So you just add the content that you feed in the journal during this phase 1. So, and then everything else works as expected. Queries is served, and you don't see any. Of course, you see an impact on the freshness because you don't get new content indexed during this period. But apart from that, crawling runs as normal. And then in phase 2, which is a shorter part of the backup, then you just do the final backup of the journal that has been sort of added during phase 1. And this is something like 10% of the total time. So the backup is now a very convenient and robust solution in search, and you can safely use that for your DR procedure if you want that. Patching and update is obviously something that happens frequently, and you should be aware of that. The sequence of how you do patching is important. Patching means Windows update, cumulative updates, service packs, and we need to be. You should follow this recommended procedure to avoid query downtime. I just mentioned that password role. If you change password in a sort of this very automated way, that cannot be sequenced in the same way. So you don't have that ability then. But for all the patching, you should do that. So basically, what you want to do is to define update groups related to the high availability roles in the farm when you do the patching. So that means you take first half of your components in one group, indicated in red here, and you do the patching there and finish that and make sure that all components are green before you go to the next step and take next group, which is all the other components, and then finally you take the primary admin component at the end, because that triggers an admin failover, and you want to do that in a separate step. So this is just a strong recommendation to do this using this sort of sequenced approach for patching. Finally, we'll mention how we typically do the replacement of a failed server, where you have high availability in the system. Yeah. So you add your new server that's going to replace the failed one. You create a new topology, you clone the topology, add components to the replacement server. You wait until this is up and going and green, and then you remove the server from the topology. And you have to remove the server from the topology before you remove the server from the farm. That's important. And then finally, as I mentioned, then you should check the status for the host controller high availability. In case the primary host controller was running on this server, you need to replace and to create a new primary host controller. It's important to emphasize that if the primary host controller is going down together with this, the failed server, it doesn't mean that sort of the dictionaries are gone. They are still there. The only thing that happens until you get a replacement for the primary host controller is that you don't get any new dictionaries deployed until you replace the primary host controller. So it's not a big problem. It's just you just need to be aware of it and do it. And if you forget it, then you will get into problems over time. So that concludes our presentation. I'll mention that we have some related resources. Some nice colleagues of us have set up a survival guide for search in SharePoint 2013. I mean, some of you may be familiar with the corresponding survival guide that was created for Fast Search for SharePoint, as a lot of people have been using that, and the community has added a lot of useful information on that page. And this is the top level for operation on TechNet. Also have some more detailed links for TechNet content. And as usual, in all these presentations, we would definitely recommend that you go to the Ask the Experts session today. It's from 6:15, and we still have hands-on labs daily. And you can meet search SMEs in the exhibit hall as well. And for those, the presentation that has been already going on early this week, you could definitely, if you haven't been able to attend them, you could pick up the recording in, I think it's 48 hours after the presentation. And then the last 3 ones is our recommendations for upcoming sessions that you should probably consider to attend. And that's, then we come to the questions. So thank you for
Thank you very much.
Your patience with us.
There are mics here that you can come up
questions,
to,
yeah.
or